Welcome to the fourth section of this Java 9 by example course. In this section, we will cover a few advanced bits of functionality that we can add to our music streaming service, such as reading data from files and loading it into memory, writing a CLI or command line interface, and writing automated tests for our application. Now, let's proceed with the first video of this section. In this video, we are first going to do a quick revision of the existing application functionality by having a look at the last version of the components diagram. Then, we will look into adding functionality in order to load data from files into memory. And we will have to enrich the application in order to better store multiple records. Just as a quick reminder, this is how our application looks like from a design standpoint. We have a few classes connected with bidirectional links, so they can communicate each way. The classes we have created are artist, which has multiple albums, which then have multiple songs each. A song can be part of multiple playlists and has multiple listeners. A listener also has playlists, which contain distinct songs. During this video, this diagram will not change. However, we will slightly change the way the data is loaded. Loading data from files is fairly easy in Java. Luckily, the Java NIO API is really good and offers one-line solutions to reading an entire file. First of all, though, we have to establish the file structure and format. The file structure refers to how are we going to store the data into one or multiple files, and the format refers to storing and separating the data in a single file. As an example, from a structure point of view, we will store the data in two different files, one for artists with albums and the second one for songs. If we are talking about the file format, we will use space delimited rows. So, if we take the first file as an example, the file will have one artist and album per row, and the album value will be delimited from the artist name by a space. The songs will be stored in a similar fashion. It's worth mentioning that since we're delimiting by the space character, the values cannot have spaces in them, otherwise the delimitation would not work. We will cover better ways to read from files and allow any value in another video. Now, let's move into the code improvement plans. As we do not know how many records we have in each file, we need to plan for a dynamic way to store the data in lists. Right now, the MyApp class stores individual records of each data type. This will change, and with the change, the code readability will improve quite a bit. We will also improve all classes to use constructors in order to avoid having to use multiple lines of code to reach the final state of an object. Finally, something that is highly recommended by the Java coding standards that we have not done yet is adding a pair of methods on each class. They are called equals and hash code. These methods are used for comparison between two instances of the same type and are very useful when adding objects into a set, since this is the way the set will know when an object is unique or not. Now, let's switch back to IntelliJ. We will start with a code enrichment, or as it's called, refactoring. First of all, let's go through every class together and create the relevant constructors. We will have to think about which fields are compulsory and which not. The author class, it can only be created with the name passed in. For this reason, we can delete the setter and make the name field final, since it will always have a value. Moving to the next class, bond. We need to create a constructor that asks for the name, since we should not have a band without a name. Similarly to author, we should make the field final and remove the setter. Let's also add a toString method. EP album. Similar story. We need a constructor to ask for the album name, then remove the setter and make that field final. It also needs a toString method. Listener. As we have not actually used the name field, let's remove it and its getter and setter. We can always add them later. Since it doesn't make sense for a listener to require some playlist, the default constructor should be fine. Moving on to playlist, it will always have an owner, and it asks for the owner in the constructor. This class looks good. Single artist, as this is similar to band, it should be written in the same way. Even better, we should move the name from both band and single artist to the abstract artist class and reduce code duplication. The constructor in the abstract artist class needs to require a name alongside the albums. The constructors in the single artist and band classes should ask for those too, and then call super. The super keyword indicates that this constructor will delegate to its parent in the abstract class. Moving on to song. This class needs a constructor asking for its name. Then the setter can be removed, as in the other classes. Song information. This class looks almost okay. To improve it, let's remove all setters and make the 4 fields final. Standard album. In a similar way to EP album, we need a constructor to ask for the album name. Since this is common to both standard album and EP album, we can move this bit of code into abstract album. We should now go again through each of these classes and add the equals and hashcode methods. Luckily, this will only take seconds, since IntelliJ has a shortcut for generating both methods at the same time. We will notice that the listener class does not have any specific field, so for now we should leave it without those methods. Same applies for the playlist class. Now that we're done refactoring, let's run the application to make sure we have not removed any key functionality. It should run without any errors. Now let's create a new class called DataLoader, which will be responsible for reading the files and loading the data. This should be pretty simple, one method loading both files at the same time and returning a list of artists. Since the albums live in the artist objects and the songs in the album objects, that initial list of artists should contain the whole data structure. We will need to declare 2 maps. One that maps from the artist name to the artist object, and the other one that maps from the album name to the album object. Now, using the NIO API, we can read a file into a list of lines like this. The resulting list will have the type string. Then we need to iterate through the lines, split the line string, and assign each of the elements to a variable. We should create a single artist object from the artist name and a standard album object from the album name. Then we should add those to the maps using the putIfAbsent method. Finally, to build the whole data structure, we should add the album to the artist object. Next, we have to read the songs file in the same way as we have done for artists. The iteration in string splitting will happen in the exact same way, with only one difference, that now we will add the new song to the album we retrieved from the map. This is all we need to do for the reading part. Let's add a quick main method and run the application. Now, if you get this exception, it is because we have not used the full relative path but just the file names. Fixing that with the full path should make the application run. Let's try again. Now we can see some output. If we go in the single class artist and add a toString method and then rerun the application, the output should be as complete as we expected. If you're wondering where do these values come from, we have created two small files and have populated them with some values. Here's how they look like. That's all for this video.